Find the first and the second terms of a geometric sequence whose third term is -1/3 and the sixth term is 9. We're looking for a sub 1, the first term, and a sub 2, the second term, where we were given a sub 3, the third term is -1/3. We're not given a sub 4 or a sub 5, but a sub 6 is 9. Knowing that this is the geometric sequence, we know that the n terms has a formula a sub n equals a r to the n minus 1. The fact that a sub 3 equals -1/3 means if we plugged in n equal 3 into the general formula, we will get -1/3. And so we have one equation, a r squared equals -1/3. A sub 6 is 9 means if we were to plug in 6 into this formula where n is 6, then we'll get 9. And this is ar to the fifth equals 9. Think of it as a system of equation, if you will. We're looking for two parameters a and r. To find r, we will take ar to the fifth over ar squared equals 9 over -1/3, where we set the ratio of the left and the ratio of the right hand side. We want to use the one with the higher exponent on the top. We see that the a canceled the 8 out, and we end up with r cubed. R fifth over r squared is r cubed equals 9 times the reciprocal of -1/3 is -3/1. And this is r cubed equals -27. So r equals -3. -3 times -3 times -3 is -27. So we have r equals -3. Knowing that r equals -3, we substitute this into the first or the second equation. A, we don't know. R, we know that it is -3, and if we squared it, we should get -1/3. This is 9a, because -3 squared is positive 9, equals -1/3. And so a equals -1/3 times 1/9. So a equals -1/27. And a is the first term. So we have a sub 1 equals -1/27. A sub 2, since the ratio is -3, we simply take the first term, multiply -3, which is the common ratio, to get to the next term, which is positive 1/9. Just to double check our work, if we take a sub 2 and we multiply -3, we should get a sub 3. But 19 times -3 is -3/9, which is -1/3. And that is what we were given. So yes,